Okay, this is a video for people who brought the standard gimbal, as in my parts list, and are having a bit of trouble with it. I was having trouble with mine, and that's why I looked for a solution. Basically, what was happening with me is when I was turning the copter on the yaw axis, it would roll. So as I would turn to the left like this, and it would roll like this, and they would be sort of combined, if you like, and it wasn't. It's quite annoying when you're trying to line up your shots for your videos. The horizon would then tilt out of place and stuff like that, and it wasn't very nice. Basically, there's a few things that I did to fix the problems. Firstly, you need to make sure that it's well balanced, which means when you move it, it should stay where it is, like that. Whenever you move it, it doesn't want to. It doesn't always want. Like if it always wanted to go to this position, it would mean that this side of the gimbal is then too heavy. As you can see, mine always tries to sort of settle in the level plane. Another thing I did was all the wires on the gimbal I removed from this arm. There's an arm here. Remove them with this little. There's a little screw here. You can remove them, and then I split them. If you look on that one's not split. I'm going to split this one as well. They come as like a ribbon. For this is the wire for the motor, and there's basically it's a ribbon with 3 different wires in it, but they're stuck together, and they're not very. They're silicone and they are flexible, but they're not. They could be more flexible if you separate them so that they're all separate. They're a lot more flexible. And also I removed the power, the plus and the minus going to the GoPro because I wasn't using them anyway. I removed them 2 wires from the output cable, and I twisted these other 2 cables that are here, and it just makes it the cables they stay up in like a loop. I don't know if you can see that. And before they were going down through here, and they were sometimes getting in the way, and they were hindering the movement. Another thing I did was update the firmware that's in the board inside here. It comes with firmware revision 161, I think, standard from Hobbyking, and I've upgraded mine to 217. That's the latest firmware that's out when I did this update. Probably the last thing I did was up the voltage on the regulator, and basically what that does is it gives the motors more power, and it basically makes them stronger, if you like. And if the wires are sort of hindering the movement, it's got that little bit more power to get by that bit of friction created by the wires. In this video, I'm going to go through all the different points and show you exactly what I did and how you can copy me. Okay, so one of the first things I did was balance the gimbal, and to do that, it should come very well balanced from the factory anyway, because it is a ready-to-fly gimbal. But if you find that you put yours in and it's not balanced, what you can do is on the back here, in this little hole, there's a little grub screw, and you can undo that and you can slide the camera that way, and that will alter the balance on this axis, like that. If it's not balanced in this axis, what you are going to have to do is either add weight to the back or add weight to the front of this plate somehow, because there's no other way of moving the camera in this axis, if you like. Another thing I did was with the wires. The wires, I'm just going to unplug this one from the IMU, and you can see they come like this, and they are stuck together. As you can see here where it goes into the plug, you can separate them. And to separate them, all you have to do is basically pull them apart, and they become a lot more flexible that way, because they're not stuck together. You're going to want to do that for all the wires that are going through the arm and to this movement here, because these wires here, as you can see, they come up the side of the gimbal, and they could get in the way before. This power cable, this video out cable, what I did is on here there were 4 wires on this. You've got the video out and a ground, and then you have a voltage input, 5 volts input, and another ground for that input. And basically what I did is I removed one of the grounds and the red wire, which is the plus 5 volts, because I wasn't using it anyway. And then I twisted this cable, and it becomes a lot more flexible than it was before. And basically all that results in the gimbal being able to move more freely, and it's not going to get, when you try and pitch the camera forward, for example, these wires are not going to hinder that movement. Right, what I've done now is I've just removed the top and exposed the board in here. To upgrade the firmware, what you're going to need to do is you're going to need to open this all up like I have, and there's a USB port in there. You're going to need to plug that into your computer, and it will do some driver updates for a start, and it should recognise the board, and it will install some drivers for you so that it can work with your computer. Once you've done that, you can go on to the next step, which is upgrading the firmware. Something else you can do is upgrade the voltage coming out of this voltage regulator. In my build guide, I advise to use 10.5, I think it is, and I've uprated the voltage on this that's coming out of this to 12.6 volts. There are risks that come with that though. If you read the comments in the Hobbyking website, you will be able to read that a few people have been having trouble with the board, the controller board, breaking or blowing up. I don't know how you want to put that, but it's the voltage regulator on the board can't handle, or they're saying it can't handle more than 2 cells. So they can't handle more than the 8 volts or the 10 volts that the 2 cells are putting out. If you actually read the box though, it does say 11.1 volts, which is the 3-cell LiPo. A fully charged 3-cell LiPo is 12.7 or 12.6 volts, I think it is. So it should be able to handle 12.5 volts without any problems. And that's why I decided to do that. Mine is working fine, I can tell you that, it's working fine, and it might have just been on the Hobbyking website that that person had a board that was faulty, and for that reason his board blew up. I would advise you do all the other steps first, and if that still doesn't, if you're still not happy with the quality of the video, you can always uprate the voltage after that. To do that, what you're going to want to do, you're going to want to remove the tie wrap, and on the back of the board I've cut a little hole so I can get to the screw, and on this you're going to want to put your multimeter onto this and basically upgrade the voltage until you get until the readout is 12.6. You could also try different voltages if you wanted to. You could go up to 11 volts for a start, then 11.5, and see what's the best for your setup. But I can tell you that mine is running on 12.6 and it's running without any problems. I just put it straight up to 12.6 because I wanted to know if it would work. Okay, so to upgrade the firmware, you're going to need to download the you're obviously going to need to download the new firmware from the link that's below this video. It's the firmware for the open source gimbal. It's called Bruggy 050 revision 217. That's what I've put on. There may be, when you're watching this video, well, there probably will be a different revision. It might be a higher number, or it might even be a different firmware version. But you want to download that and open that, extract the files, and you will get all these files here. To upgrade the firmware, you're going to need to download Arduino as well, the Arduino tool. You want to open that. Hopefully you've done what I said before and you've got the drivers installed correctly. If you haven't, you're going to want to find the drivers for your board, and you're going to want to open in Arduino one of these files here. Which one did I open? This one here at the top, brugni.ino. You're going to want to open that file there, it's on the top here in Arduino, and you're going to want to, it will automatically open up another window, and it will open up all of the files here in different tabs. And that's how the Arduino software works. You don't need to change any of the text that's in there. you're just going to want to click on the options and select your control board, and you're going to want to set it to an Arduino Pro Mini 16 Hertz, and then you're going to want to click on upload, and it will go through the text and make sure everything's correct, and it should upload it without any problems. What you're going to want to do once you've done that is you're going to want to unplug it and plug it back in again, and that will reset the board. And then you can go into this folder up here, the GUI, and you can open up blgtool.exe, and you can open that up, and that will open up this window here. Now on this window here, let's bring that into the middle. On this window here, you've got different settings, and this is where you can change all the PIDs for your gimbal. Firstly, you're going to want to make sure you can get a connection. So you're going to want to click here, and I've got two COM ports that have been selected, that have been detected by the software. I think this board is 13, but I'm not sure, to be honest. I'm going to try 13 and click connect and see what it does. And there you go. It will go Bruggy ready, and that means now that it's connected to the board itself. You can actually click on Start Waveform View, and you will see here this line starts to move across. And if you actually move the gimbal itself, like I'm doing now, you can see you can see the output from the sensor, basically. What you are going to want to start off with in here is most of the settings are, in the first settings tab, I didn't change anything. I haven't changed anything in there. Most of the settings that you're going to change are going to be in these first two tabs here, PID pitch and PID roll. RC pitch, I don't think I changed much in here. I used the pitch from the receiver to control where my gimbal was looking up and down, and it was these two settings that I changed here: RC min, RC max, and 0 offset. These two here control the endpoints, if you like, of where when your switch is in the up position, which is the highest point the gimbal can go to, and when your switch is in the lowest position, the lowest point the gimbal can go to. I've actually got my gimbal set to it so that it goes to about 85 degrees, pointing vertically down. I found that if you go over 90 degrees, I had trouble with the gimbal coming back up on the wrong side, so it was pointing upside down looking at the copter. But if you don't go over 90 degrees, you should be fine. That being said, these numbers in here, they don't have any relation to the amount of, well, I don't think they have any relation to the amount of degree, the angle, if you like. For example, here I've got mine set to 96, pointing down, and that doesn't really relate to what it actually is. It's more like 86, if you like. The 0 offset on this one is the midpoint, if you like. You don't really need to set this to, you don't really need to change this on the pitch. I've got mine set to minus 120, and I will explain why in a few minutes. But you shouldn't need to change that on the pitch. On the RC roll, if you change that, the 0 offset on the roll, obviously changing on the RC roll now, we're on the RC roll tab, changing the RC min and RC max isn't going to actually change anything, because this gimbal doesn't come with the input for the roll from your receiver. However, changing the 0 offset is going to change the center point, if you like, and mine's got set to now 0.4, because I found that it was slightly off level at its midpoint. Another thing that you can do is ACC calibration and a gyro calibration. I think I did the ACC calibration, then I reset it and it went back to 0. To be honest, this isn't very badly documented, what these buttons actually do. But the gyro calibration, I did it once, set it, and then I turned off the gyro calibration at startup, and I found that to give me the best results, or the most consistent results, if you like, because it saves the settings in the EEPROM and it doesn't overwrite them every time you turn it back on. In the auxiliary tab, I didn't change anything, because this is more for different hardware versions that have got more inputs and options for there's a new mode called Follow Me and stuff like that, and it's you can change that in here, but you don't really need to use the auxiliary tab. PID pitch and PID roll. These are the ones that are probably going to have you pulling your hair out in aggravation. I would advise what you could do is you could copy my settings here, which I'm going to include a screenshot probably at the end of this video. But basically I've got my P, my I and my D, and they are 15, 112 and 32. And I've got the reverse ticked, motor 1, and the max PWM is set to 21.2. That's the pitch. And the roll, I've got the P, the I and the D. The P is 40, the I is 271, and the D is 90. And the max PWM is 32.8. I've also got that one set to motor 2, and it's also got the reverse clicked. This is basically trial and error. What I normally do is I start with the P. I'll up the P until it starts to vibrate, and then you can reduce the vibrations with the D until the vibrations go. And the I found the I to be the amount of stabilization that actually goes into it. Again, this is very badly documented what these actually do. The people that develop the firmware, they obviously know what they do, but there's not very much documentation on the internet about what they do and how to tune them. It's very much trial and error. I would advise you start with my settings here that I've got and work from that.